One of the main purposes of building automation is to save energy and money. But what happens when an alarm goes off? This is when proper fault detection and diagnostic comes in handy. Without this, alarms become confusing and cluttered, which leads to wasted time and money. If proper fault detection and diagnostics is used, a building can save their energy consumption up to 15%.
How does proper fault detection and diagnostics actually help a building save money? Well, if you're in an office building and it's just too hot, people complain all the time. So when the alarms are going off, everyone ignores them. How do you know it's an important alarm? Well, smoke alarms, obviously, if there's a fire, you need to evacuate. For some buildings, it's humidity. For other buildings, it's temperature. You have to have a conversation with your customers to figure out what alarms are important to them. For example, in a hospital, in some of the rooms, the air quality is the most important. So when something goes down and everything's beeping, you want to, during the fault detection and diagnostics, you want the air quality alarms to be pushed to the top so that you can diagnose the biggest problems first.
Even when you prioritize alarms, there still can be just too much data for a technician to go through in a reasonable amount of time. See, this guy, he's trying to figure out a problem, but there's all these numbers and he's frustrated. He doesn't know what he's looking at. Then you go over here, and this technician actually has some useful data. He still has all the numbers and the problems, but they highlight the main problems that are causing the rest of these. So this is called a cascade of alarms. An example of a cascade alarm would be a cooling coil valve that is not opening, which is causing the rooms that it is serving to become too hot. So when a technician sees this, he could see 100 rooms or he could see 1,000 rooms, depending on the size of the building. But he has to sort through that and try to find the main problem right here, the cooling coil valve. So to eliminate this waste of time, we can use logic to block out the unnecessary alarms and only focus on the main alarm.
This brings us to the false alarm. I mean, we have the right alarms installed, we have the temperature alarms, but on Saturday, some people decided to move stuff into their office. They prop the door open, the temperature spikes up to 80 degrees, and immediately the important alarm that we set with our customer goes off. Beep, 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 beep. Look at that. And the poor technician has to drive all the way out to that office building because of the false alarm, because no one notified him. When he gets there, the movers are like, "What are you doing here?" And he's like, "Well, isn't the building hot?" They're like, "Isn't the building always this warm?" Because they're not used to it. This wastes the technician's time, it wastes the company's money. So you don't want to use single authentication alarms that only rely on one thing, temperature. We want to use trend alarms. Trend alarms can either rely on one thing of temperature and monitor it over a long amount of time. So on Friday, the technician goes, building's working. On Saturday, for a few hours it spikes, but it comes back down. The technician isn't worried, it came back down. On Sunday, as he still watches it, it stays flat and even, so he knows the building's working. That's using a single authentication trend alarm. Or you use multi-factor authentication, where you use multiple different readings to know if there's actually something wrong. It could be 80 degrees in there with the supply air. The chilled water return is 45 degrees, meaning it's not properly heating up, and the pressure drop across the filter is 3 inches of water column. All of those things would be fed into a logic controller, processed and sent to the technician's computer that would say the filter is bad because they're all working together and our programs are using logic. The technician can then grab the right size filter, walk over there, check it out, replace it if it's bad, and this saves time and money.
The summary and results. Number 1, find important alarms to customers. Talk to your customers. See what they want out of their BMS system. But the number 1 priority is always health and safety. We want our customers to feel safe, and we don't ever want anything to happen to them in their working environment. Second thing is to minimize raw data being shown with alarms. This will prevent single value alarms and prevent cascade alarms. This will save a technician time, energy, money. It'll save his company money, and it'll save the customer money as well. And it also save them on their energy bill. And the third thing is use trend values for alarms. This can show what is going on with the system, where the issue might be. For this example, there's 3 York pumps. They're all communicating through a BMS system, and we have a trend line set up with kilowatt hours and time. As you can see that hot water pump one is using a lot more energy than these other 2 pumps, 2 and 3. They're pretty close together, steady going, but pump 1 over time keeps continuously increasing. So without a trend line, a customer might notice this on their electric bill, and it will take time to figure out what pump is actually causing the issue. With the trend line, we can clearly see that pump 1 is the issue, so we can quickly resolve the problem and save time and money and energy, which is the main point of a BMS system.
Look competent,
Quick troubleshooting,
have a badass BMS system.